Okay, what's up, dude? So we're back. We're gonna do another session here. We're gonna do 1 hour. I'm gonna go ahead and timer. I'll give us 68 minutes to add that extra 8 minutes. Those little 8 minutes add up. So we did do 1.5 hours almost exactly. So put this 1.5 hours after 30 would be 1 o'clock. So then you're adding 18 minutes. So we're looking at 1. I think something like that. And yes, we did 1.5. Well, and do from 316 to we stop. And it's bothering me. Okay, and from to 118. What did we do? We evaluated whether we should use pickle or JSON for our save file option, formats option, I guess you would call it. And so yeah, we're jumping back in at 316 and let's go. All right, baby, let's do this work. Okay, and we determined that we're going to probably use, so yeah, we're JSON back in at 316. Sure that my stream is working. Yeah, it's working, baby. And let's paste that in. Whoa, didn't mean to click the thumbnail there. All right. Sure that my. All right, yeah, it's working, dog. Cool. Okay, let's go back over here and. Right. So yeah, we were determining whether or not we're going to use JSON or pickle or another option. We determined that. And we can put this in notes. This is something we can save. We can put JSON versus text versus import. JSON is 3x faster than import and 2x faster than text. Roughly, you know, that was a general. That's a good general statement, and that's just. I want to remember that because I kind of thought that importing would be faster, but that's part of learning and my misunderstanding of the truth. Okay, so we were looking at. Oh right, what types of data that we're gonna need to save to our save file, and that was gonna dictate whether or not we're gonna use pickle or JSON, because JSON, I don't actually know if JSON is faster than pickle. So, is JSON faster than pickle? So it's creating a benchmark for JSON versus pickle, and it's creating a test data with, this is, what is this called? Type annotation or whatever. Type hints. Isn't that called type hinting? Out of free messages until 5. Damn. So we're never gonna have to switch over to ChipJip. What's this? Called type hinting in Python. Alright, so we'll ask ChipJip. And we're going to continue. So we have the by tree may look okay, create test data, dig string, any, create a nested data structure with various Python types. Nested data structure with various, so we have return integers. list range of 1000 floats. Okay. Times 100. Okay. Ooh. A list of lists. A mixed. Ooh. I like it. Okay. Def benchmark JSON. So I have JSON string equals JSON dumps the test data. Okay. So it's JSONifying that data. Then it is deserializing that data. And then it's going to return the length of the JSON string. I don't know why we would return the length of the JSON string and not... Why do we do that? Why do we return the JSON string? I'm confused about that. But I'm out of free messages, so I actually can't continue to ask Claude. Okay, so then we have benchmark pickle, serialization, pickle bytes equals pickle dumps test data. It's the exact same wording. Syntactically, pickle loads, pickle bytes, return length, pickle bytes, create test data equals create test data. Okay. Create test data. Righty. We have iterations equals 10,000. Then we have run benchmarks, test data, size, and memory. Size of the test data. Okay, so that's getting the okay, cool. JSON time it, benchmark JSON number of iterations, pickle time it, benchmark pickle. Okay, JSON size equals the length of the JSON dumps. But didn't it already return the length? Or, well, the serialized sizes equals JSON dumps. Okay, so okay, it's seeing the size of the data. Oh, well, I mean, I don't really care about the size difference so much as I care about the speed difference. The input data is the same, so you know. Results for iterations. 10,000, iterations. Okay, right. Print. I'm just gonna put it format, time, seconds, relative speed, size, bytes. Gotcha. Okay. Fastest time for relative comparison. Fast time equals min JSON type equal time results. JSON type JSON size. Pickle time size. For format name times heights and results. Relative equals times. For format name time size in results. I didn't know you could do that. For format name time and size in results. Relative equals time divided by fastest time. Print f format name time and then relative. So you got your in results. Okay, I see. Because you're unpacking. So it's going to be JSON, the JSON time, and then JSON size, and then okay, yeah, gotcha. Print notes. Each iteration includes both serialization and deserialization. Benchmark JSON. So benchmark consists of serialization and deserialization. Time and performance can vary based on data structure complexity. Pickle can handle more Python types, but is less secure. Pickle can handle more Python types, but is less secure. Right? We're not worried about security in that sense. Because it would only affect each relative client. Like it's not going to be transferred over a network to another client, and it couldn't be modified by the client for malicious purposes to be used against another one. It can only be used against themselves. And as far as I understand it anyway. So I actually can't even ask him to run this code. So I would actually have to run this code. But what did he say? Did he tell me which one he thought was faster? Did it run the code? Okay, running this shows that for basic data structures, JSON is often faster, produces a larger file size, serialization is simpler, complex data Pickle becomes faster. Pickle produces smaller files, and Pickle handles Python-specific types better. Python-specific types better. The program depends heavily on data structure complexity, data size, Python, whether serializing or deserializing, and hardware speed. If you need security and human readability, if you need single data, best performance, benchmarking for specific data structure. So I will just literally run the test. I will copy this and I'll run this on my machine. So let's just go over to test reminders. We'll go to next test segment, which is, that's how we know where our next test segment is going to be. Baby. Oh, so now we ruined our copy that we had because I do that frequently. This, now we're gonna paste it in. Alright, so let's see if this works. We'll just try to run it straight up and see what kind of error we get. We're gonna move into testing. That's not right. See, testing. Now we're gonna do test. Reminders. There we go. Alright, running benchmarks. Okay, so it's running. Okay, there we go. Wow. Test data size of memory 184 bytes. Okay, so it looks like, ooh, Pickle, is that much better, really? Pickle smoked him. Pickle smoked him, dude. Pickle smoked him. Ooh, okay. Alright, so looking like, man, Pickle really wrecked Jason there. Baby. So we have, it's 4.25 times slower Pickle. It's also a larger size. So Pickle is smaller and faster. So yeah, like we're gonna go with Jason here. Is there anything in this test that may have? We don't need the length of the Jason string, right? Like, do we need this? Benchmark JSON. What do we use benchmark JSON for? So we don't even actually use this return value. Or am I just wrong and we do? Well, I didn't save it, but it's autosave, so it should have been saved. Okay, yeah, so without the return, we still get the Pickle being extraordinarily faster to a extraordinary degree. It is so much faster. Yeah, it's like 4 times faster, and even if we do it multiple different times. Yeah, so this was actually generated by AI, boys, and that was really great. AI did what it would have taken me about 30 minutes to do this. I mean, well, I could have done it a little uglier in like 5 minutes, you know what I'm saying? But he did it in 2 seconds. But it took me like a 30-20 second prompt, so you got to count that in. And but yeah, for simple stuff like this, What is great. So we're gonna give this a title. We're gonna call it Jason versus Pickle, and of course, I love matchups, baby. I just love matchups. You know what I'm saying? I love competition. You know, Goku versus Vegeta, you whatever. This versus that, and man, I gotta tell you, I was not disappointed here. Jason got smoked. Pickle, Jason versus Pickle, or we'll just call this, yeah, Pickle way fast, 4x faster. For simple. And it said that Pickle would become faster for more complex Python operations. So like basically if it's faster for smaller, simpler, then, and it would almost certainly be better for larger and more complex, then that pretty much rules out using JSON at all. You know what I mean? The thing with JSON though is that it is compatible, cross machine compatible. So like, or cross language. So if you have interacting systems and the JSON is coming from another system with another language or whatever, then that's when you would need to use like JSON. I don't think you could use it. But anyway, in a general speed test, for serialization and deserialization, Pickle, baby, that Pickle is fast. Pickle was 4x faster than Jason consistently. Not just once, but frequently it was faster. So we're gonna go with Pickle. So let's go over to Jason, and we are, yeah, we do have to ensure that it can handle bytecode. I mean, like, what does that even mean? Well, hold up. If something is already being sent over as bytecode, doesn't that mean it's already serialized? Like, it's already... So we wouldn't even need to... We wouldn't, like, it would actually... I don't know why I didn't, like, this didn't just click off the bat, but... We can do it even so much faster by using Pickle, because Pickle is what we use currently for data transmission, to serialize the data. So whenever we're doing data serialization and deserialization, we're using Pickle currently in our project, which means when we send anything over the network, whenever we receive it, if we want to save it immediately, which is what we want to do before we do anything else to it, before we even deserialize it, we want to save it. So if it's already serialized and serialization is the method that we would want to use to save it, then that means we are already we're already there as far as like the data is already ready. All we have to do is write it to the file. We don't have to serialize this data because we're using a pickle file. It's already been pickled, so we can just straight up like bam, save it. We don't have to do any other operation on it whatsoever. I didn't really think about that. So yeah, we're gonna use pickle. Of course it can handle bytecode, because that is what, when you pickle something, when you pickle data using Python, does it turn it into bytecode? Yeah, I'm pretty sure the answer to that is yes. And let's look at this dict_string any. Is that called type hinting? Yes. Dict_string any is an example of type hinting in Python specifically. The dict_string any part indicates that the function will return a dictionary where the keys are of type string. The values can be of any type. So the string key and any data type for val, the dash greater is syntax is used in function annotations to specify the return type of the function. For example, from typing import dict any, def get data, dict string any, return name Alice, age 30 is student false. So yeah, cool. Type hinting overview, argument type hints. You can also specify types for function arguments. You can also specify types for argument type hints. You can also specify types for function arguments. So greet, name, string, age. So that's what it returns. It returns a dictionary where the list consists of the key type and the value type. And we have def greet function where the tuple, or rather the args, are succeeded by a colon and then the data type, so string, name, and then for the age parameter, and then the return value is to be a string, which is why we return this f string, and the arg name is going to be a string and age will be an integer. So this is properly formatted. And we have return type hints, which is the dash greater than symbol followed by this type specifies the return type. And then we have optional, which is type hints are not enforced by Python at runtime. What, baby? Right, they're not, and that's something that people criticize Python for, is not having forced type, what do they call it? Type, it's like, type something. Anyway, it's very important to many people. They don't use Python or don't like Python because it doesn't have that feature. So there's views on this feature, the fact that it's not enforced. Anyway, type hints are not enforced by Python at runtime. They're primarily for improving code readability, static type checking, static type checking using tools like MyPy or IDEs. Let me know if you like AD into Python type. Okay, understand. When you pickle data using Python, does it turn to bytecode? Yes, when you pickle data in Python, it doesn't convert it into bytecode. The format Python uses to execute compiled PyC files. Instead, it serializes the data into a binary that can be written to a file or transmitted over a network. This binary format is designed specifically for Python objects and is used to preserve the structure and data for later use. Pickling is the process of converting a Python object into a byte stream. So it's not byte code, but it is converted to a byte stream, and it's in binary format. The byte stream can then be saved to a file, sent over a network, or stored in a database. Deserialization is unpickling is the reverse process of reconstructing the original Python in the byte stream, and then it's not bytecode. Bytecode is an intermediate representation of Python code for the interpreter. Okay, it's unrelated to pickling. Right. Okay, so that's like compilation. That's converting. Yeah, it converts for it at runtime. The interpreter has to translate Python into bytecode. And bytecode is not serialized in Python. It is different. It is interpreted Python. Okay, pickling focuses on object serialization and deserialization, not. Right. Okay, I understand. But pickling is a binary representation of the object, but it's not directly human readable. You can think of it as Python-specific serialization format. Only unpickled data you trust as malicious code can be executed during unpickling. Cross-version compatibility. Pickled data might not work across different Python versions or implementations. Okay, let me know. Show example of byte code versus serialized code. Okay, byte code example would run the script Python automatically generates Python when it executes. Okay, so he didn't actually show. Okay, so there we go. So this is the output, and this is the byte code. So the byte code looks like this: load const, load fast, binary add, return value, hello name. So that is completely not what I meant when I say bytecode. When I said bytecode, I actually meant not even that either. I really meant like, anyway. So that's what pickle looks like. And it's using CSS. So this, I don't know why it says CSS. Name QX, Alice QX, student Q. Okay. So strange. That's what pickle looks like. And then that is what it's a SCSS file, and this is for bytecode. So fast binary add return value hello name. Gotcha. Very cool. Okay, so bytecode executes Python code efficiently. Instructions for the Python VM virtual machine, I guess. PyC is the extension. Automatically compiled by Python. Used to speed up program execution, and then serialized code stores Python objects for later use. Serialized data in binary format. PKL are custom, explicitly created using pickle. Right. Okay, so it is like. So those question mark symbols, etc., actually represent complex. Was it binary code, like bytes, like is this, I just want to make sure I got this down. Yes, there's question mark symbols and other unintelligible characters you see when opening a pickle file and a text editor represent raw binary data. They're simply displayed that way because text editors attempt to interpret binary bytes as text using a character encoding like ASCII or UTF-8. However, the actual content is binary data bytes that isn't meant to be human readable. Right, so it would. Okay, I understand. Cool. Breaking it down binary format. Pickled files or any binary file are just sequences of bytes. So pickled files are just sequences of bytes, baby. Gotcha. Or any binary file. Each byte is an 8-bit value and can represent anything, number, sex, or even complex Python objects. For example, using the string hello in binary would look like this: HELL. Oh, gotcha. And then we have serialized objects. Pickling converts Python objects into a structured binary format that encodes the object type, properties, and data. When viewed in a text editor, some parts might appear readable, string data stored in the object, but most will look garbled because it represents non-textual binary data. Serialize this dictionary data name Alice age 30 student false with open data pickle WB. What is WB? What does WB stand for? I know it's W is right. What does WB stand for? Okay, so you have this X happened here is the question mark and other odd characters are binary values that can't be displayed as text. Readable parts like name and Alice are plain strings, so you can read them, such as Alice right here, and then you can see name right here. But all this is like, you know, this is like code for data equals a dictionary. And then this right here, X5, is like next, the value. This is like code for value, and then you got this is code for that value, and so on and so forth. So a bounty of values that can be displayed as text. Readable parts like name and Alice are plain strings stored in the object. Interpret as bytes. You can directly view and manipulate the binary data. So yeah, that's specifically built for Python. So those symbols are like Python structures. The interpreted display format. Gotcha. Directly view and manipulate the binary data as bytes in Python. Parts like name analysis, plain string, sorted an object, interpreted as bytes. You can directly view and manipulate the binary data as bytes in Python with open data pickle RB as RF. Raw data equals F read. So you can directly view and manipulate the binary data as bytes. Okay. Output binary. Right. This is what I was talking about. This is what I meant. That's what I meant right there, baby. So interpreted as bytes. You can directly view and manipulate the binary data as bytes in Python. So when you open up the pickle and read it, and you do fread and you print it, this is what prints out. And that's what I meant. That is what I say bytecode. I thought that's what bytecode was. But apparently that is not called bytecode. I thought that was bytecode. So that's not called bytecode. What is it called? What is this called? I don't know. Each /xnn is a hexadecimal representation. So this is hex code. Hexadecimal representation is a byte. /x80 means the byte has a value of 128. It's binary bytes. Okay. So it can. That is still binary. It's just a byte. It's each one of those is a byte, right? Yeah, is a hexadecimal representation of a byte. E.g., x80 means the byte has a value of 128. Why it looks strange in text editors and coding mismatch. Text editors are designed for displaying text in formats like UTF-8 or ASCII. I just messed up my screen. There it goes. Came back. Fix this timer. Alright, you see why it looks strange in text editors. Text editors are designed for displaying text formats like UTF-8 or ASCII. When they encounter raw binary data, they try to interpret it as text, leading to garbled symbols or question marks. Binary files aren't text. Okay, so basically the question mark probably means it literally just doesn't have a way to represent that data. So it just gives you a question mark. So binary files aren't text. Pickle files are structured for Python to understand them, not humans. So binary files are not text. They're structured for Python to understand them, not for humans. Gotcha. So imagine trying to interpret a QR code with your eyes. You'll see just patterns of black and white squares, but a QR scanner interprets it as encoded data. Similarly, binary files like pickle data are meant to be read by programs, not humans. So binary files like pickled data are meant to be read by programs, not humans. So pickled data are meant to be read, not humans. Gotcha. Okay, so what does WB stand for there? In the context of handling, WB stands for write binary mode. It is used with the open function to write data to a file in binary format. So write means write mode, open the file for writing. If the file already exists, it overwrites the file. If the file does not exist, it creates a new one. B, binary mode, specifies that the file should be opened in binary mode instead of the default text mode. In binary mode, the data is written as raw bytes, not as human readable text. Binary mode is essential when dealing with non-text data like images, serialized objects, for example, pickle or any other binary formats. So binary mode is essential when dealing with non-text data like images. It's essential when dealing with non-text data, like images, serialized objects, any other binary formats. So you import pickle data equals this. You write it to the file as binary, and you're serializing it first, so it's serialized or binary. It's converted to binary. It's serialized pickle in binary format. If you don't use B or instead just use W, Python will attempt to interpret and encode the data as text, which will fail if the data contains non-text binary values. For example, pickled data is inherently binary and cannot be written in text mode. Let me know if you'd like a more clarification or example. Gotcha. So that's not called bytecode. What it's called? It's called byte stream or binary serialized data. So that's not bytecode. I called it bytecode. That's not what bytecode is. That is byte stream. That is a byte stream, not a byte code. Gotcha. /x number hex code is not byte code. It's a byte stream. The result of serializing or pickling objects using the pickle module. Specifically, B indicates it is a binary string, a sequence of bytes. And X represents a single byte hexadecimal format. X80 is the byte with the value 8. This byte stream encodes the structure and content of the original Python object like a dictionary or list into a format that can later deserialize. It is not bytecode. Bytecode is an intermediate low-level representation of Python source code generated for execution by the PVM. PyC files and PyCache contain bytecode. You can inspect Python bytecode. Blah, blah. Okay, got you with the dis module, but is unrelated to pickling. Non-human readable. Byte stream is optimized for storage and transmission, not for human readability. It's only meaningful interpreted by the pickle module. Terminology: the serialized data can be referred to as a binary byte stream, pickled data, or serialized object. Serialized object. Got you. So this is serialized. This is serial code. Hex code, serial code, byte stream, pickled data. So here's how pickling generates a binary byte stream. Gotcha. When you pickle data and print it in the Python interpreter, this is what you will get back. That's what I was really referring to. Anyway, so the byte stream is now the binary serialized form of the dictionary, not bytecode, but data serialization in the pickle format. Serialized data, bytecode, intermediate instructions, PyC, dis module, serialized Python objects, no binary representation. And then file extension is PKL or similar. If you'd like to dive deeper into either serialized data or bytecode. Gotcha. I need to raise up my monitor because my posture is dictated by where my monitor is located. Otherwise, I have to look down or I have to just have bad posture, and I'm trying to fix my posture. So that's requiring me to kind of look down at my code instead of, because I be like this, but it's actually bad posture, and they call it. That's why you get tech neck and stuff, and I suffer from neck pain associated with it. But anyway, okay. So long story short, we now know why we're going to use JSON, and of course it can handle bytecode, which is not actually called bytecode. It is actually called a byte stream. We call it a byte stream. Or we can also call it hex code, hex bytes. That's not we're not going to call it that. No one calls it that. That's made up. We'll call it a byte stream, which is what they call it. Okay. Instance objects, yeah, we don't need to worry about that. So we're just like, we can just delete this instead. We know that we're going to use pickle actually, because pickle is faster, and we're already using pickle actually. So we made that decision, so we can not benchmark this, we can report this in our devlog. Determine that we are going to use pickle as the better option for saving data. Alright, now we're moving on to the next thing, and we only have 28 more minutes left, so let's try to be productive, which is more like 25 minutes because I have to save a rather stage commit and push these changes to our remote repository and create a local backup. So what we need to do now is we actually need to do the code, implement the code that is, for loading in game ID from the save file using import or read, and we're going to use read because it's faster. So we'll put using uh, cs save file dot pkl read. So that's what we're gonna do. We're gonna have, we'll put cs, and we'll just write this. Well, we can just actually have this as pseudocode, right? We'll just do cs save file dot pkl. Or can we do a context manager which automatically closes? We say with CSA file.pickle, and then we do, how do we do this exactly? Let's look here. So we say, let's go back up here. Okay, yeah, with open. So let's comments, because I'm actually not familiar with doing file operations. So we have save CSA file.pkl, or rather, we need to change this to with open. So we're using open, and use single quotes because I just like to use single quotes here. CSFO.pickle, and then we're going to use comma, and we want to not to write but to read. We want to read the, and we want to read it as bytes because it is screen. Okay, so if we have already connected and saved the game ID, right? Which would happen later on, then the game ID would not be equal to none. But in the case that we are opening this file and we have not yet received the game ID, meaning we have not started a new game as of yet, then we will have that value equal to none. So we're opening the CSA file pickle with the RB for read in byte mode, and because it is going to be serialized data, which is why we would read it as bytes instead of as text. And then we're going to do pickle dot dump. Do we do pickle dump or pickle dot load? I thought we would use, when we're receiving, that is, let's see, when we receive, let's go to N and then receive here. Let's look at this, how this is. So we have current header string using socket decode. Alright, so that, alright, so when we receive the data, we use pickle loads to deserialize. So dumps serializes it, and loads is deserializing. And it seems kind of like backwards, right? You would think that if you're dumping something, you're like gonna deal with it. But when you're loading it, like I would think when you're loading something, think of like loading a truck. You're putting it into this container that is serialized data. But actually, pickle.loads is the opposite. Pickle loads actually deserializes the data. Loads deserializes while dumps serializes. So if you ask, yes, exactly, you've got it right to the breakdown. Pickle modules dumps and loads. So dumps takes in an object and serializes a Python object into binary byte stream and interprets it from an object to a byte stream. Loads deserializes a byte stream back into a Python object. So dumps converts a Python object dictionary list into a byte stream that can be stored or transmitted, and then you have loads, which takes the binary data byte stream produced by pickle dumps and reconstructs the original Python object. So loads is deserialization, which is a reconstruction, and dumps is serialization. So if you're dumping, you're serializing, and if you're loading, deserializing. So loading in this sense means deserializing. Kind of like the opposite of what you might think. So loading is deserializing. So we want to load for deserialization. So we say pickle dot and, or is it dot load? It's loads. It's loads and then dumps. So pickle dot loads, and then we are okay, so here's a problem though. How do we get the, how do we find this data? Like how do we grab it in the we'll say pseudocode loading in game ID from save file using CSV. Right, so we have with open CSV file pickle RB, I think that is correct, and the context manager will ensure that it's closed after the operation automatically, the file that is, and then we're using pickle loads, and we say question mark, question mark, question mark, because we don't know how do we find the proper data in the PKL file, right? Because this is it's basically encoded. How do we find a particular data structure / var inside of a PKL file using .read? So, like, wait a second. Let me I'm a little bit off here in my understanding. We have with open CSA file pickle R. So yes. Yeah, we want to deserialize it. So, but even if we deserialize it, how exactly do we grab it? Yeah, I don't know exactly how we do that. After it has been deserialized. So let's look at this. If you're working with files instead of in memory, use dump and load instead of dumps and load. Okay. So here's something I didn't know about. We have dump versus dumps and load versus loads. So if you're working with files instead of in-memory byte streams, use dump and load instead of dumps and loads. So dump and load serializes a Python object and writes it directly to a file. So this is something I'm going to have to determine, is how do we properly handle this? Let's see. So this is new to me. Save receive data CS prior to deserialization. Need to say, yeah, that's true. Network.receive to add code that does this. We use .dump /load or dumps /loads. Says to use dump for files and dumps for byte stream. Need to learn more about this. Okay, and then we're dealing with the, we'll call it the load in game ID at begin CS scripts. This is created on the 12th. Alright, and we're determine how to use dumps or loads, etc. to properly access the game ID val from the CS save file.pkl, baby. Never did this before. This is need to understand better. Yeah, I need to understand that much better. Okay, so we got 14 more minutes. Just gonna stretch real quick. Alright. Let's 13 more minutes, baby. Let's do this. Alright, so let's finish strong here. I'm getting fucking tired, not gonna lie to you. I'm ready to go. My neck is killing me, bro. I don't know what I did exactly, but my neck is fucking hurting me. Alright, so let's read this, because give me a long answer. Okay, so we said exactly, you've got it right. Here's a quick breakdown of the pickle module, dumps and loads functions and how they work. So, dumps serializes, loads deserializes a byte stream into a Python object. Okay. Dumps converts a Python object into a byte stream. That's serialization. Dumps, serialization, load, deserialization. Now, it says if we're working with files instead of in-memory byte streams, which is what we're doing in this case, we would use dump and load instead of dumps and loads, because so we would actually use load. We're going to load the file. We're going to read serialized data from a file, deserializes it back into a Python object. So yeah, how do we know which data is which? You know what I mean? Like, so we have with open data pickle WB as F, pickle dump data okay, and then we have deserialized with open data pickle RB as F. So that's what we need to do. We need this, and we're gonna load that file, and when we print the loaded, so this is gonna, yeah, but what if we have more than one data structure? You know what I mean? What if we have more than one? And that shit got so hot, dude. This heating pad gets like crazy heat, crazy hot. Let's go over here and paste this in. So, space this out. Make sure we got room here. So we have with open data pickle RB. So that's what we need to do. We need to have with open CS file pickle RB, and we'll just call it as C. Let's call it S as S, or we'll just call it save file. Then do pickle load the save file. But how do we find? So we're gonna say find proper data in the PKO file, which is the game ID. So that's what we need specifically from it. We need the game ID from this file. Get rid of that now. Okay. Let's keep reading the what it said. Summary: dumps serialize, loads deserialize. And this is for in memory. So with S, plural is for in memory, but when we're working with a file, it's no S. File, no S. In memory, in file, use S. Dumps serialize, loads deserialize. Dump serialize, loads deserialize. And I just have trouble remembering that for some reason. So how do we find a particular data structure var inside of a pickle file using a read after it's been deserialized? If you deserialize a pickle file, the resulting Python objects is a dictionary, list, or other nested structure. It's loaded into memory. Once you have the object, you can interact with it as you would any other Python variable. If you're asking how to locate or extract a particular data structure or variable from within it, here's a step-by-step approach. So we deserialize the pickle file. So deserialize the pickle file into a Python object. So import pickle, deserialize the data from L with open. Okay, load data. At this point, load data contains the entire object that was serialized. Yeah, but okay. What if we have more than? If the object is dictionary, example 2 is the object of the list. Search dynamically. If you're unsure, you can search dynamically by checking keys in dictionaries. Letter data, no. Redirecting, no. Using read with raw data. If you only use read to be working with the raw binary data, this could be. No, that's not what we want. No, I mean, what if we have written multiple serialized Python objects into a save file? How do we access a particular data structure var that we previously saved into it after we unpickle the loaded file? If you deserialize pickled multiple Python objects into the same file sequentially, you need to read and deserialize them one by one in the same order they were written. Each object will need to be read using separate pickle load calls. How to handle multiple serialized. The pickle doesn't natively support named or indexed access to individual objects in a single file. Instead, it processes the file as a stream of pickled objects. You have to call pickle load repeatedly to retrieve each serialized object in the same sequence they were written. So, writing multiple objects. You can write multiple objects to the same file like this. Okay, with open data 1, data 2. Okay, right. So you have to like know. Okay, so this might not be. If you don't have any objects, you can loop until the end of the file is reached with open multiple objects pickle RB as F. While true, try pickle load the next objects append, and then break. So you have the objects, which is a list containing all the various data structures. Gotcha. Since objects are read in sequence, you need to access them in the same order they were written. If you know the position of the object, just call pickle load enough times to reach it, for example, to receive only the second object. Okay, so alternative, storing objects. If you ever need to access by a name or key, you store your objects in a dictionary and pickle the dictionary as a single object. If you need easier access by name or key, store your objects in a dictionary and pickle the dictionary as a single object. Okay, so now we're faced with two options here. Basically, one of them is we would okay, I see what we can do. I see. So like we would have. I'm thinking. Well, that doesn't work though, because I was gonna think we would write it into the save file using like a dictionary to say that we would basically create a template that has all the different data structures / variables, whatever, that we're gonna save to the save file, all those namespaces as like keys to a dictionary, and the values would be default to none. And every time we saved to the file, we would save basically like to the associated key. But that would not, like, I'm not sure that wouldn't necessarily be possible in the way that I'm thinking using pickle, because the pickle file itself must be in pickle format. So if it contained a pickled dictionary and we wanted to basically add to that pickled dictionary, we would have to, like, well, we would have to, like, basically unpickle the dictionary, right? And then, like, modify it and then re-pickle it. Am I understanding that right? Anyway, I'll address that next time. For now, I'm gonna go call it quits, and yeah, we'll address that next time. But that's a good question. This actually might result in us going back to JSON. It depends. If it's still faster to, like, do it that way with the dictionary and pickle versus using, like, plain JSON English dictionary writing to have that dictionary template be, like, updated as we are updating the file. I need to understand this this a little deeper before I can figure out a solution. It's fuzzy because I really just don't completely understand it. I haven't worked with it enough. So, save receive data CS prior to deserialization, load in, determine how to use them. So we're going to put this at the top of the list. So let's put this up here, and we're going to say, essentially, the issue here is with using pickle is that the save file has the data stored as binary, therefore we would have to unpickle all of the file's data to find the data structure / var we want. Solution, we could create in Python file dict that has each key / index of that has each key index, or has each key index and the key index order stored as a client adder or something like that. This would allow us to access the proper object via reference to that saved dict using key / index num. We would always have to store / save data to file in a particular order / via particular index / key. Is this actually possible? And then solution number 2 would be, could use alternate option of JSON to create English dict order inside of JSON file and reference that in a similar manner for index/key order reference. I mean, this is like kind of fuzzy, but I basically, you know, kind of, I understand what I mean, and I'm just gonna put that we stopped here. So we did really good, actually. So this is line 17, and we also stopped. Let me actually, we'll do it like this. We'll say stopped here slash at line number, let's see, 326 in client refactor. So 326 in refactor pi. Yeah, baby. All right, there we go. So now we're gonna go over to devlog. That we stopped at line number, what is this? 17. And things to do. Slash text. All right, and we worked until 4:27. We continued working on how to ID data from serialized file and refactor. Right, and now we're going to stage and commit our changes, and also we're going to push them to the repository. So we're going to do 428 to 430. All right, I'm getting excited. I'm getting excited, so excited, because I know I'm done for the day. And we did 1.5 plus 1 1/4, so that's 2.75 if my math is correct. So we're going to copy this as our devlog. Now we're going to cd out to the root of the project directory. We're going to get the branch, and we are on the correct branch, so we can do git add everything, and we're going to successfully stage our changes. We're going to commit using -m, double quotes, devlog paste, double quotes to that devlog message, hit enter, successfully committed our changes with 10 files changed, 119 insertions, 8 deletions. Now we're going to do git push Canasta secondary to push to that remote repository, and that will do the trick for us. There we go. So we have successfully pushed our changes up to the cloud, baby. Fix your posture, dog. Make sure, because I think that's contributing to my back being messed up, is my back posture. We created a shortcut to our recycle bin. Just did it twice. Alright, so let's create a local backup. So we're going to go to projects, Canasta. We're going into, we're not going to go into, we're going to go to Canasta backup. We're deleting the old one. Now we're going to paste in the new one. We're going to ignore this warning. We're going to go into this copy, pasted in copy. We're going to go to devlog and all the way to the end, and that is going to let us know that that weird voice in the background. That's creepy as fuck, dude. I never noticed that. I just noticed that. That's some demonic shit, huh? Anyway, so yeah, that is the correct date for today, as far as the devlog. So that is indeed the correct copy, and now we can change the date to reference last time it was locally backed up, which was today, which is the 12th. So now we have a local and a remote backup, and we are done for the day. Baby, I hope that you enjoyed this as much as I did, and that you are going to have a good rest of your day. We are going to continue chipping away at this. We're making good progress, learning new things, going into different areas that I've never went before with Python, and just learning new stuff is really exciting for me. The process is obviously a lot slower for getting things done because it's kind of learning as you go, as instead of doing that rote repetition work that you already know how to do. You're learning how to do it, and then you're actually doing it. So it takes way longer to actually make visual progress. But overall, I'm really happy, and I think that um, we're on the right track as far as just overall from a bird's eye view working with the project. And I think we should be able to wrap up this, what you call it, menu screen feature implementation with the save file connection pretty soon. And then we just have to test. We're going to test out our game to ensure that our menu screen works properly, and then after that we're going to um, have to create the really complicated code that is going to handle dynamically saving the data, and will dynamically reload data, etc., for whenever we have those reconnects. So that is a different ball game. That is going to be its own monster, a completely different monster that we have to face. Probably a lot more difficult than this one, honestly. But things are really difficult until you get to them, and then you start to just break them down into smaller pieces, and then before you know it, you've created a solution. You're a better programmer. You graduated to the next level, and now the next time you do it, it's going to be really easy, or a lot easier than it was. So anyway, have a good day. I'll see you guys next time. Be safe.